So this video is about bond energy, and we want to explain what that is and what the signs mean, and therefore that's what we do. So bond energy. All right, bond energy is the energy that's stored in an atom between two atoms, not in an atom, between two atoms. Right, the energy stored in the bond, and um, like this is hydrogen that's got a bond energy, and then you think of a bigger molecule, something like this. Each each bond has its own energy. All right, this would be the bond energy between carbon and hydrogen. This is carbon to carbon, carbon to oxygen, and so on. And they each would have their own respective bond energy. It's not, this whole thing doesn't have a bond energy because you wouldn't look at it. It's not of a molecule, it's between two atoms. All right. Okay, now, one other thing about bond energy that I want you to know is the values are going to be given to you. This is our textbook, the TRO chemistry. You can see there's a big table of bond energies there. And you're not going to be expected to memorize any of these values. You are going to be expected to know, like, the higher the bond order, the higher the bond energy. But these values would be given to you. All right. Now I want to really delineate what they are and what they mean about two atoms. So bond energy is the energy stored in a bond. All right. Like this, it's between these two hydrogen atoms. All right. Now they can have, the order means like single, double, triple, like in carbon. All right, nitrogen is another one. Oxygen can make a single and double with itself. It can also make a triple bond with carbon. And actually, carbon-oxygen bond is the highest, as the most energy. Now I want to talk about their signs. If you looked in the book, the values that are given are all positive. All right. Now they're expecting you to know something about these bond energies. In that, they're all positive. That means that's the energy required to break the bond, and it's also the energy that is released when the bond is formed. All right. So nitrogen, it's 160, a single bond between two nitrogen. To make that bond, 163 kilojoules per mole would be released. So this would be negative, and you need 163 kilojoules per mole to break that bond. So there, negative. All right, that means you're releasing the energy to make it, when you make it. And opposite, when it's positive, that's how much you need to snap it. All right, I want to go over one example. So there's the bond energy for oxygen, and this is for the double bond, O2. And that would correspond to both of these bonds being made or both of them being broken. It's going to be all of our units are always going to be kilojoules per mole. All right, and in a chemical equation, it would look kind of like that. All right, and then the opposite is, the reverse is true. If I want to break them, I'm going to need to add that energy. All right. What about methane? Does methane have a bond energy? The answer is no, because methane is this. Each one of these has its own bond energy, each bond between carbon and hydrogen, and that's 414. All right. A CH, that would be, so the total amount of bond energy in a in a methane molecule would be 1656 kilojoules per mole, estimating it. All right. but that's not that's of the molecule of itself. A bond energy is really just between two atoms. All right? Hope that helps. Have a good night.